Hi everyone, welcome to our CodeDay Labs Tech Talk on our resume screening project. Our team consists of Abhishek, Anna, and I, along with our mentor, Sneha. In our talk today, we will first go over our problem statement and motivations, then give a brief overview of our solution. Then we will dive into more details about our solution and do a demo. Lastly, we'll talk about what we learned, further work that can be done, and how to contact us. This is our problem statement. Design a system using Tensorflow that classifies a resume based on its potential fit for different job categories. We have several motivations for designing a resume classifying system. First, we wanted to create a faster system for classifying resumes. This can reduce the amount of human effort needed for recruiters. Furthermore, not only do we want to help companies and recruiters, we also wanted to help applicants. Applicants can use this system to improve their resumes before applying to jobs. Lastly, we wanted to improve current resume classification systems, which have some limitations. Current systems can only be used by companies, so they're not available to applicants to get feedback. In addition, many of these current systems don't use machine learning, which makes making changes like adding more job categories and retraining the classifier more difficult to do. The goal of our solution is to classify resumes into different job categories. For example, Java developer, business analyst, data scientist, and more. And we use a dataset that consisted of many of these job categories. Our solution included a machine learning model for classification. This model takes in the text in the resumes and classifies it into one of the job categories, and also depicts the confidence in the category choice as a percentage. Our solution displays the top 5 categories the resume got sorted into and the confidence percentage for each category. We also deployed a trained model on an HTTPS server. We tested our solution on one of our teammates' resume, which will be shown later in the demo. Now Anna will talk about the project pipeline.
Thank you, Alison. Hello, everyone. I'm Ina. So let's go through the training model pipeline, which consists of 2 parts, data analysis and pre-processing, and training the model. So let's go through the first part, which is data analysis and pre-processing. So once we get a data, it's very important to first analyze the data before actually jumping into the training model part. Because the classification problem here consists of categories of data. So we must see whether all the categories have a balanced data set or not. It should not be like one category should have only one data point and the other categories have 100 or 500 data points. So it leads to highly class imbalance. Then the second part comes is pre-processing the data, which is actually extracting the relevant features from the data set. And the third part is splitting the data set into training, testing, and validation set. The dataset that we are using in this particular project is a resume classification dataset, which consists of 25 different categories. And the dataset size is 1,000. And the right-hand side, you can see the number of data points corresponding to each category. The diversity of categories is so large here. You can see there are mechanical engineer, Java developers, data science, business analyst, advocate, and so on. So this is the data distribution of our categories, and we can see that this distribution is very important to understand whether the classes are balanced or not. So we can see that apart from the Java developer, all classes are kind of balanced. It's not like very imbalanced in the data set. Every category has good number of data points in the data set. Then comes the data cleaning part. Since we are working on text data set, which we may get from docs files or PDF files, it's very important to eliminate the useless words which might just increase the neural network size and which will increase the number of parameters by a lot and make the speed of training very slow. So there is a very good library called NLTK, which is an NLP library, which has stop words package. And this actually eliminates like all the English stop words from the dataset, which includes pronouns, punctuations, verb links, and symbols. Further, we wrote one function called clean text to remove other things which were not covered in the stop word library, which includes URLs, hashtags, or other symbols. Once we have that, we apply it as a Lambda function to dataset, and we get a clean version of the dataset. So you can see the left part of the picture is the original raw dataset of a data science person, and on the right, it's actually the clean version of the same dataset. Now it's time to prepare the data set for neural network model. So how it's done? Our computer does not understand text, right? So we have to convert that text into something which machine actually understands. And this is done with a library called tokenizer. And this is called data tokenization, which is a process to convert text to a format which machine actually understands. And it is performed on corpus to obtain tokens. And by tokens, I mean something which is used to prepare a vocabulary. In other words, vocabulary is a set of unique tokens in corpus. So this is done with a word to vector library under the hood of tokenizer. And for that, we have to define a hyperparameter called vocabulary size, which is taken as 6,000 in this case. So what it does is it actually takes the top 6,000 words of the vocabulary and compare those words with the words in the dataset. And if those words are not present in the vocabulary, then they are considered OOV. In other words, out of vocabulary words. So you can see in the picture that we on the left hand side we have a resume, and the tokenizer extracts all the words which were in the resume and which are also in the top 6,000 vocabulary size. You can see in bold on the right hand. Let's go to the second part, which is actually training the model. So our model actually consists of 4 layers. One is an embedding layer, which is a layer to learn embedding for all words in the training data. So in other words, it actually learns a vector space of dimensions in which all words will be embedded. Then we apply a max pooling layer, which is used after the embedding layer to reduce feature size, and it's used to downsample the incoming feature vectors. Then we have 2 fully connected dense layers, and you can see the last dense layer's output consists of 25 nodes. For each resume data, it will actually spit out 25 probability values. We train this model for like 25 epochs. Uh, so while training the model, we actually split the data set into 3 parts: training, testing, and validation, where training is 70% of the data set, entire data set. Validation is 20% and testing is 10%. And this curve, the orange and the blue curve, corresponds to test and train performance respectively. So we can see the accuracy is able to reach 1, which is pretty good. So now Abhishek will talk about the model deployment and real-time performance of this model.
Thank you, Anna. Now, let's take a look at the web server architecture. First, the user interacts with the server by entering their resume in the browser window in text form. The server itself was written using Node.js and Express.js. Within that, we use Pug, which is a dynamic platform for HTML, and CSS for styling the windows. Then, once the user has input their resume text, we use a Python subprocess to import the TensorFlow model that we trained earlier, which will allow us to perform classifications on the user's data and return a result back to them using the Node.js server. Now, let's take a look at a snippet of the server-side Python that does the classification. So imagine at this point that the user's data has already been cleaned and tokenized as we did with the training data earlier. And then it gets to this code. Here, we use the Keras library, which allows us to load the model that we saved from our training process. Then we make a prediction, and as Anna mentioned, this prediction is an array of 25 values where each value represents a probability, and the sum of these 25 values will be 1. So the index of each prediction corresponds to a specific label from our categories of resumes, and each value in those indices represents the model's prediction probability that this resume fits into one of those categories. Then we use the built-in NumPy library to find the indices of the top 5 most likely categories. Then, for each of those 5 categories, we print the new label and the probability back to the user. Now, let's take a look at a snippet of the server-side JavaScript. This is in the index.js file, and this function on screen represents what happens when the user clicks the submit button on our platform. So first, we require child process because we want to be able to start a Python process from the index.js file. So here, when the user clicks submit, we call a post function, which is why we have router.post for this index. And then we start a process and we pass in the body of the resume to this process so that the Python script can access the value that the user input and then thereby run classifications on it. Then here you see we have process.standardout.on as a function. So what this does is when the Python script prints something, that data gets piped to this function. in the variable data. So here when we see the variable category equals data.toString, anything that was printed from the Python script will now be in category. And then since each print is separated by a new line, when we split by this regular expression, we get that the category will become an array of each of those results from our Python script. So then, once the process is closed, we send the data that we got in the category array, we send that back to the index view so it can be presented to the user. And thereby, they can see their top 5 results along with the probability that their resume fits each of those categories. Now let's take a look at the project structure for this web server. In the root directory, we have app.js, which basically stores all the roots in our web server, and then we have package.json and package.lock.json, which are required files for Node, and then we have requirements.txt, which stores all of our requirements for our Python dependencies, and then we have readme.md and .gitignore, which are files important for our Git repository, and then we have the Python script that does all the classification, resume screener.py, as we saw earlier. And then in the bin directory, we have the www file, which in this case is the start script for Node. And then we have the public directory, which contains the CSS style sheet for our platform. And then we have the roots directory, which contains only one file, index.js, because we only have one page for our web platform right now. And then we have the views directory, which contains the pub files for web page content. And then we have the assets subdirectory, which contains subdirectories with our dataset, model, and other data processing objects from our Google Colab notebook, which have been saved using the Keras library for the model and the Pickle library for other data processing objects such as tokenizers and dictionaries and things like that. And then we have 2 other directories for Node modules and virtual environment, which contain the dependencies needed to run Node and Python for this project. Now, let's take a look at a short demo of this project. So here, we have the resume screener in action. You can see it's running on localhost on my machine with Node. So I have the text form of my resume copied in my clipboard, so I'm going to paste it in this text box right now. There we go. And then I'm going to click submit. And we have to wait a few seconds to let the model do its work. And after about 10 seconds, we see that the top 5 results for my resume are data scientist, sales, .NET developer, Python developer, and DevOps engineer. Now, I'm going to hand it over to Allison, who'll talk about her lessons learned from this project.
Working on this project taught us many lessons. We learned about agile methodologies by using Jira to keep track of what tasks need to be done and what tasks have already been completed, and by having stand-up meetings with our mentor Sneha twice a week, during which we all share what we were working on. We learned about code collaboration using IPython notebooks by using Google Colab. We learned about version management by using GitHub, where we uploaded different versions of our code. We learned how to use Tensorflow and some of its libraries, such as Keras, to build our model. We learned about end-to-end model training and deployment. And lastly, we learned about multi-language web development through using Python for the classification and JavaScript for the server. Now, Abhishek will talk about further work.
Thank you, Allison. Now let's take a look at some further work we could use to improve this project. First, we could deploy on Heroku with a custom domain to allow more people to access the project. Next, we could expand the dataset with more resume categories and train our classifier to handle those categories. Then we could also investigate more complex neural network architectures to give a better accuracy on our model. And we could also allow the users to upload PDFs and documents and use optical character recognition to extract the text from those documents. We could also develop models that analyze the details in the resume rather than just the words that are present there. Building off of that, we could also develop models that can give feedback to users that allow them to improve their resumes. Here, feel free to contact us. This is our contact information. You have our email and LinkedIn for each one of us. Thank you for watching.